All right, it's 12 o'clock. It's Wednesday. It's time for the Iowa Learning Farms Conservation Webinar. I'm Matt Helmers with Iowa State University and excited to get to co-host or to get to host again today, moderate our webinar. Uh, if this is your first Iowa Learning Farms Conservation Webinar, welcome. If you're a repeat viewer, thanks so very much for continuing to come back. I think we have a super important topic today. I guess all of them we have are important, but this is one I'm really interested in. So we have with us Matthew Streeter and Calvin Wolter. They're with the Iowa Geological Survey at the University of Iowa. Matthew is an assistant research scientist, and Calvin is a GIS analyst. They've been doing some important work on assessing sediment sources, nutrient storage, and long-term sustainability of farm ponds in southern Iowa. So I think this is a really important topic as we think about many of these farm ponds that have been put in and maybe how we think about managing them, maintaining them into the future. So with that, I will turn it over to Matthew and Calvin. As always, if you have questions, please type those into the chat box. And at the end of the talk, I'll get those to Matthew and Calvin. We'll see if we can break the record from last week on how many questions we get. There were a lot of questions last week, which was great. So with that, Matthew, the virtual floor is all yours. And Calvin, sorry, Matthew and Calvin. I was looking at Matthew. Matthew and Calvin, the virtual floor is all yours.
Thanks, Matt. So I'll take just a couple of minutes and give a little bit of an introduction here to what we're doing, and then I'll turn over really all the nuts and bolts and the important stuff to Calvin. But just want to kind of iterate the kind of long-term relationship that the Geological Survey has had with the Nutrient Research Center, looking at different conservation practices in Iowa and those nutrient reduction benefits. And a couple of years ago, we decided that we'd really like to start looking at farm ponds more in terms of dissolved nutrients, and had a little bit of funding to move into southern Iowa and specifically into Soap Creek watershed, which I'll show you in a second. And we started looking at dissolved nutrients like nitrogen and phosphorus, and quickly found out that in Soap Creek watershed, there really wasn't any contributions. There wasn't any nitrate to be had, so the processing was also very low. But still thought that these ponds are really interesting places to work. And so we kind of shifted our focus over to looking at sediment storage in these ponds. And through that kind of relationship with INRC, we just had a paper published in the Journal of Soil Water Conservation that was looking at this sediment storage in these permanently filled farm ponds in southern Iowa. So to give you a little bit of a background about where we're working, we're on the southern Iowa Drift Plain in southeast Iowa. Soap Creek watershed is mainly in Wapello, Davis, Monroe, and a little bit of Appanoose counties draining to the Des Moines River. We had three different farm ponds that we were really focusing in on in Soap Creek watershed. And I'm going to zoom in a little bit here in a second, but I'll show you just kind of an example of how many farm ponds there are in Soap Creek and why this is an interesting place to work. Overall, Soap Creek's about 163,000 acres. There's over 2,500 ponds in Soap Creek watershed. So every one of those red dots on the map is a pond. So lots and lots of ponds. But Soap Creek specifically is really exciting because over the last 30 years, really about 30 years ago and 20 years ago, the NRCS invested in about 135 sediment and flood control ponds in the watershed. And these ponds are really unique because they have pre-built, kind of as-built surveys for the ponds. So we know what the landscapes looked like before the ponds were put in. We know what the landscape looked like once the pond was built. And that gives us a very unique opportunity to study sedimentation in those ponds throughout their lifespan. So to zoom in on Soap Creek just a little bit, this is in the kind of the northwest portion of the watershed. One of our study ponds is the one here with the blue circle around it. But just kind of, I think, this shows just the magnitude of ponds that are in Soap Creek. So every single one of these red circles is representing a pond, and I may have even missed some on the landscape. So just lots and lots of ponds. Most of these are put in for livestock watering or things like that. But again, these 135 specific ponds that the NRCS put in were related to flood control and sediment storage. So that's where we're working. And to highlight just a little bit about the land use in Soap Creek watershed, it is very much predominantly perennial grass and forest. Just a very, very small portion of the watersheds are in row crop. So we have three different catchments that we were looking at for our study. Notice that the highest catchment, which also is the smallest one, but the highest percent row crop was only 10 and 14% kind of throughout the lifespan of the pond. But Soap Creek overall on average is only 13% row crop, so mainly perennially vegetated. I'll zoom in on our three different catchments that we're interested in. Again, the pond that we're actually studying is the one with the blue circle, and I just highlighted again those other ponds that we find in the catchments. But so this is one of our sites where it's almost entirely in timber ground. We have another site that's paired with that site just to the north, where the catchment has many more ponds in it, but a lot of CRP ground, a little bit of pasture and timber kind of all intermixed in that catchment. And then the final catchment, this is the smallest catchment and the one that has a little bit of row crop right in the very upper end of the catchment in one small pond. This is our smallest watershed. So I'll give you one more slide here just to kind of iterate what we had to work with at the beginning to look at these ponds and then what we did as far as sedimentation is concerned. So what you see on the left are these as-built designs and these contours maps that are built by the NRCS. And this really gives us our time zero or the basis with which we have to work with to understand sedimentation in the ponds. And then on the right, is what we did to estimate the amount of sediment within the ponds. We actually took manual measurements through these ponds and went out and did a couple of transects and then used a kriging method to come up with a sediment surface for the ponds. And based on the original time zero contour maps that we had, and then that kriging, we were able to come up with a total amount of sediment that we were actually seen stored in the ponds. So that gives us really what's happening in the pond itself, which is fairly simplistic, but it's what we had to work with. And then Calvin took over from there, and he really did all the work on the catchment and the erosion aspects. And so I'm going to turn it over to him and let him really dig into this GIS difference tool, which is pretty fantastic.
Thank you. So with Iowa, we're very fortunate that we have two different LiDAR-derived DEM data sets that are available for the whole state. The first one was done between 2007 and 2010, had a vertical accuracy of 37 centimeters in vegetated areas and 18.5 centimeters under bare earth. And then we also recently had the one completed in 2020 that had vertical accuracy of 18.5 centimeters under vegetation and 9.25 around bare earth. And you can see the two different hill shades there. How much better the 2020 shows up the resolution and the depth of the stream channel and the gullies showing up. So because of that, we can then do a difference calculation or a DEM of difference method of geomorphic change detection. It was developed by a company called ESSA up in Canada. And there's their website. I found this tool a couple of years back. And so what you can do is have two different data sets, an old and a new one, some time frame between them. And using a probabilistic method, we can look at, say, like the 95% probabilistic change in difference between these two data sets. And when we do that, here we show the difference calculation where the red is erosion, and of course the darker the red, the greater the erosion. So you can see some of that right in the middle is around 5 meters deep. But you can see the gullies that have formed are going up the channel on the upper left and even in the middle. And then you can just see in the lower left-hand corner, they put a pond in between the two LiDAR data sets. And so it actually shows up as deposition. Here is the difference calculation for this pond 2651B. You can see in the main channel and the lower channel, there's quite a bit of erosion going on in the channel and up those drainage ways or gullies. But then also you can see towards the pond on the right-hand side, that light blue showing the deposition that's occurring in that flat area just above the pond. So with this difference of DEM calculation, we can calculate how much eroded, but also how much was deposited. So you can get a net erosion calculation. Here's another pond with the lower right. Once again, you see just above the pond, there's a lot of deposition occurring. But then up in the drainage ways, you see a lot of gully and channel erosion occurring. And you can also see where 2 ponds were put in during that 10-year time frame. And this is our third one, the smaller one. This one, you don't really see much deposition occurring in the area right above the pond, but you do see the erosion occurring way up in the drainage ways near the headwaters. So by doing those calculations for each of the 3 watersheds, we could estimate the total volume difference that's going into those ponds. And then from the calculations Matthew did with the pond sediment and how much was remaining, we could calculate the difference between the two to see if the ponds are filling up any faster or on schedule with what they were planned for, the 50-year time frame. Want to jump in?
So essentially, just based off those difference calculations, we found that the expected remaining capacity was much greater than the actual remaining capacity for all 3 of these ponds. So we have, quite a bit different size of each of each pond. 3 different size ponds, 3 different size catchments, but all are really showing the same thing. That they're filling up faster than what was expected. So our remaining capacities, example for 90-91, which is the smallest pond, has a remaining capacity of about 35%. It was expected to be about 40%. So maybe that's, relatively close, but filling up a little bit faster. When we get into these larger catchments and the 51B and 51C, which is where we had the largest catchments and the largest amount of timber ground, that these are filling up even faster than that. So, 41% remaining capacity compared to that 60% remaining capacity. And one thing to note here and probably that needs iterated is that the error associated with the DEM doesn't allow us to look at things like sheet and rill erosion in the catchment. We're specifically honing in on the gully erosion that's occurring in these landscapes. So in the timber ground and in the CRP ground and in the pasture ground, it's all of the gullies that are actually making these contributions. So we came up with this net erosion rate ultimately to the pond. So we've got deposition that's occurring somewhere in the catchment. It's not all making its way to the pond, but we have this net erosion rate of sediment, presumably all derived from the gullies that's actually making its way to the pond. And we compared that to our actual pond sediment surveys. And in the bottom right here of table 3, you can see that this is the actual percent of sediment compared to the erosion that we're actually able to account for. So we're able to account for over 90% of the sediment in the pond based off of these erosion estimates that Calvin did using the difference tool. Ultimately, I think kind of showing or iterating that it really is a gully-dominated system. We're able to account for a lot of this sediment specifically from those gullies, especially in perennially vegetated landscapes. Now, I want to go through a couple of other results because this isn't the entire story. This isn't exactly how we got to this 90 or so percent for our sediment budget. So here's just a figure that's showing the eroded sediment. This is the sediment that was calculated with that difference tool. And then in blue next to that, we have the sediment from the pond. And then you'll see that on top of that pond sediment, we do have a modest amount of sediment that we're calling exported clay. And so what we found when we did the sediment surveys in the ponds, we actually sampled these sediments for nutrients and particle size analysis. What we found is that the percent clay, or the soil texture, the percent clay of the sediment in the ponds was much lower than the percent clay in the average for the catchment. So that, and of course, our catchment data, we didn't actually sample that. That was all based off of Surgo data and estimates for that subsoil. But our clay in the pond was much lower. And we're assuming that that portion of clay that's lost essentially was suspended in that water during flow events. So anytime that the pond's actually flowing, we might be losing some suspended clay particles. And so when we make that assumption and we look at the difference in clay percent and then make some estimates of bulk density, we can come up with those values from that previous slide where we're accounting for a little bit more of that eroded sediment as completely lost from the pond from that clay fraction. So again, I mentioned that we didn't just look at sediment, we were also looking at nutrients, and there was really not a big story to tell. We started off with 10 or 12 ponds actually, and we were looking at dissolved nutrients, nitrogen and phosphorus. And frankly, there's just not a big source in these types of environments. We had a dozen ponds, and I think maybe two of them really had a source of nitrate coming into the ponds. And even with that source of nitrate, there was a very large amount of reduction in the ponds. But primarily, there's just not a source for those dissolved nutrients. And so we were looking at just the stock of nutrient in the sediments within the ponds. And so we measured the total carbon and the total nitrogen, just combustion analysis of the sediment to look at that. We also looked at Bray phosphorus, which is just a basic test in soil organic matter. And ultimately, we are definitely storing carbon and nitrogen and some phosphorus in these ponds. And there's a nice story to tell there. And we were able to, based off of the size of the catchments and the age of the ponds, of course, the ponds do have a bit of varying age. We were able to come up with a rate of nutrient accumulation in those ponds. And ultimately, they're not, I wouldn't call them huge values, because in general, the environment is that it's perennially vegetated. These are timber grounds. They're not cornfields where we have high carbon or high nitrogen and phosphorus levels to begin with, but still significant areas where we can store these nutrients. So that in a nutshell is what we did for the ponds. And Calvin has a few more minutes, and he's going to share another project that we've been working on with this GIS difference tool just for a few minutes, because it's really exciting. But I'll say just one last thing about the ponds before we kind of switch gears and talk about the difference tool again, that we're very much still interested in this work. We now have the ability to do drone-based bathymetry surveys in the ponds, and we would very much like to go out and look at other land use catchments, look at more of the row crop catchments, and do more specific sediment surveys of those ponds. So we'll continue to work on this. But with that, I'm going to let Calvin switch back over and take just a couple more minutes and talk about other things we're doing with the difference-based LiDAR.
Thank you. So a couple of years ago, we started doing a study on the Old Man's Creek down in southeast Iowa that flows into the Iowa River. And we published this paper early last year of using LiDAR-based DEM elevation difference calculations to estimate the net stream bank erosion in that Old Man's Creek watershed. And I'll just show you a quick slide here. On the right is the map showing that difference calculation once again, with the red being erosion, blue being deposition. And you can see that the deepest erosion areas are over 6 meters deep, but also the deposition is up to 5 meters deep. But those bands of red and blue that you see there over this 11-year time frame are like 30 meters wide. So there's a lot of erosion occurring in this watershed along these meanders. And we just looked at the fourth and fifth order streams. We did the difference calculation and came up with 720,000 cubic meters being eroded, while only 148,000 cubic meters were deposited, which is a 5 times difference between the two, which shows that This stream is way out of equilibrium where you would expect the erosion to be more in line with the deposition. So this erosion rate, net erosion rate, is 570,000 cubic meters, which we also have the DNR has a monitoring site on Old Man's Creek, and over that time frame, we estimated that the 570,000 cubic meters was about 77% of the sediment being exported from that watershed. So this just reiterates the importance of this stream bank and gully erosion as being a very high percentage of what's going out of our watersheds these days.
Yeah, so just to kind of reiterate that for the implications of what we're doing, we saw or listened to a great talk even last week that was really focusing in on infield soil erosion and infield movement. We've done a lot of work on sediment delivery ratios here at the Geological Survey over the past 7-8 years, and I think overall we're seeing that infield sediment export, actually delivery to the streams, has decreased significantly over the last 50, 60 years. We've really done a really great job of holding sediment on a landscape in an agricultural field when we use practices like no-till and strips and terraces and things like that. On the other hand, we're still exporting a huge amount of sediment, but the source is really significant kind of skewed towards these banks and towards gully erosion and places like that. So these are areas where we should really be focusing research on how do we stabilize these streams, how do we reduce sediment loads derived from bank erosion and gullies and things like that. And this difference tool that Calvin has been working on has just been absolutely fantastic to help us to highlight those actual sources of sediment. So, Calvin, do you have anything else to add to that? Or
No.
Okay. So with that, I'd be happy to open it up to questions.
Let's do these. Let's get to our last logistical slides. You guys can catch your breath. People can start typing in questions. I want to thank our key partners in helping make the conservation webinar series possible: the Iowa Department of Agriculture and Land Stewardship, the Iowa Department of Natural Resources, the Iowa Nutrient Research Center, and the Leopold Center for Sustainable Agriculture. Without their support, these would not be possible. So thank you very much. Let's go to our next slide, which should be, if you need a CCA CEU, please email Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today, including your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. Let's go to the next slide. If you watch this webinar live and are willing to fill out this voluntary demographic survey, we'd greatly appreciate it. Only one survey response is needed for all 2026 webinars. So if you've done so already in 2026, thanks so very much. And if you're willing, please scan that QR code or go to the website there. Okay, next slide. Okay, we got more thinking about soils. I guess this is now we're going back in field again, but we got Dr. Humberto Blanco from the University of Nebraska-Lincoln that's going to talk about conservation tillage effects on soil health and carbon. We'll go to the next slide. This and all other webinars are archived and available on the webinars site. So this would be somebody asked about the copy. So this you could go and watch the webinar again and see the slides again there. Okay, this is we're getting some great questions coming in.
I have one more, Matt.
Oh yeah. Oh gosh. Yeah. Okay. I wasn't doing my job. Thank you for keeping me honest, Matthew. The Iowa Learning Farms crew will greatly appreciate it. It saved Elena sending me a chat saying, Matt, there's one more slide. So, okay. Please tune in next week, March 12th, and evaluating manure application and cover crop planting timing to maximize water quality benefits in corn. So we're going to have Dr. Dan Anderson and Dr. Raj Raman and Philip Roxon talking to us on 12. So put that on your calendar. That's not, again, the virtual field days are not on Wednesday. Those are on Thursday. We just want to confuse everybody, I guess. And it's also at 1 instead of 12. So tune in then. Okay. So let's get to some of the questions, those that we can. And so when you were looking at that difference method, Calvin, you were just looking at areas that were not in surface water, because somebody asked about the LIDAR doesn't penetrate water. So you're looking at those areas kind of what I think is kind of upslope from where the ponds are, if I'm correct.
Right. We used the polygon of the pond as a separate area. And so
Okay.
that was taken as kind of a constant between the two data sets. So we did not include that area for any difference calculation.
Okay. And
And
now,
then also, Calvin also accounted for the ponds in the catchment themselves. So there were new ponds that
Right.
were.
So any ponds that went in, I removed that deposition from the calculation.
yeah. Okay. Yeah. Like that one that you showed where there was that blue area down in the lower
Right.
left corner.
Correct.
Yeah. So a question on that one slide, you had kind of the expected remaining capacity. You probably said it and I missed it. How was that calculated?
So we have the as-built designs from the NRCS,
Okay.
and those as-built designs have essentially an elevation where the outlet pipe is for the dam, and of course, once the sediment fills up to the outlet pipe, the pond is considered full. And they're also engineered to have a quote 50-year lifespan.
Okay.
And so we were looking at the that portion below the outlet that we had left, the volume that we had left compared to the expected 50-year lifespan.
Okay.
And so that's how we had that 40% and 60% expected volume, and then compared to what we actually measured.
And I'm assuming kind of that expected remaining capacity, and based on in the design would have used kind of what they estimated the kind of delivery rate of sediment might be to that. So my question might be, if they're filling up faster, might some of that be due to maybe increased intensity of precipitation that we might be seeing over the last couple of decades compared to maybe what was in the design assumptions, I guess, for these systems?
Yeah, I think that's a really reasonable assumption. So
Okay.
we have to go back and really look at what the factors were that they were using to assume rates of
Yeah.
erosion in 1993 when the ponds were put in, and then 1998. So we have ponds
Okay.
in 93, 98, 2002. And of
Okay.
course, yeah, that changes over time.
Yeah. Okay. There was a question that, the LIDAR DEM analysis you did can account for sheet and rill erosion. Could Russell 2 be used to supplement the DEM difference analysis? Could that explain some of the difference between actual and expected sedimentation in the pond?
You certainly could use Russell 2, or you could use a wet watershed an analysis to look at erosion from sheet and rill sources, but it won't help to fix our budget. If anything, it'll make it worse because we were not able to account for all of the eroded sediments that Calvin found with the difference tool. We were only able to account for a little over 90%. So if we do find that we do have some sheet and rill erosion occurring in those perennial fields, which of course should be pretty minimal. But if we do find any, it'll actually make that budget slightly worse than it is now. We won't be accounting for even more of the erosion.
Okay. But there is a margin of error in that erosion calculation, so we're still within that margin of error. It's about a 20% margin of error on that DEM difference calculation.
Okay. And I'll just reiterate that this was a pretty basic sediment survey of the ponds, right? So these were physical measurements that were done in transects around these ponds, and there's certainly room for some error in that. So I'm really excited to have this drone-based bathymetry capability that we now have at IIHR at the University of Iowa, and so we can go back and get some I think, very accurate sediment surveys going on in the future.
Okay, great. Um, so there are a couple questions about this tool that you use, Calvin. They ask if it does it run only in ArcMap or does it run in ArcGIS Pro? And then how accessible is it? Do you need to be a researcher to generate reasonable estimates?
Okay, so the tool was originally developed in ArcMap and was a product toolbox that you could import into ArcMap. For ArcGIS Pro, they do have a standalone version, which is what I'm having to use now because at the University of Iowa, we just have ArcGIS Pro. So you just do the DEM manipulations in ArcGIS Pro, put them into a location, open the standalone tool, go to those grids, import them, run the tool. It spits out a difference grid, and then you can pull that back into ArcGIS Pro. And I put the website up there again for people who want to find that. It's a free download. As far as using the tool, so our LiDAR data is great, but it's not perfect. Surprise, especially the older one. And so I've had to do a number of manipulations to smooth out, especially in the stream area, things that weren't quite right. But other than that, then it's just a matter of clipping out the portion of the stream bank that you're interested in, both the old LiDAR and the new LiDAR, and then put that into the tool, and it spits out a new grid for you. It is a rather particular tool in that your two grids have to be exactly the same location and projection. So
Okay.
your grid cell size has to be the same, and your grid projection has to be the same.
Okay. Thanks. Was the unconsolidated nature of sediment in the pond sediment surveys taken into account when volumes were compared to the consolidated nature of the soil on the landscape?
Yes, because we also have bulk density measurements, so
Okay.
they were normalized in that way.
Okay. There were a couple in here about the let me see here. Sorry, everybody. I'm trying to kind of. Oh, yeah. So that bank erosion sediment, was that, I guess, from your work in this area, was that from kind of you think previously deposited from field erosion or old sediment?
Well, I think since some of those locations were 6 meters in deep,
Yeah.
that it's a combination of both of
Okay.
those.
Yeah.
I don't know if you've done any work down in Old Man's Creek, but I would imagine there's at least a meter or two of post-settlement alluvium in that floodplain.
Yeah, easily more than a meter, at least a meter post settlement.
Okay. There was a question if these study and results are these study and results being shared with NRCS and other stakeholders? Certainly we have some NRCS people on here, but I didn't know, I think somebody was asking if there's somebody from NRCS that wants to hear more from Matthew and Calvin, not to put them on the spot, but I bet they'd be willing to share this information.
Yeah, absolutely. We're excited to chat with NRCS folks about it. I've talked to a few just kind of on a more private basis, but definitely happy to share, present in those kinds of meetings. Had a great meeting with IDALS folks about this last week, and
Okay,
I
great.
really do think that we should be considering this when we look at future, pond implementation. We want to make sure that the federal dollars are being used to the best of our abilities. So.
Yeah, I guess that, there are a couple questions like what would be, any insights you have for the future on, what, re potentially removing the sediment from some of these areas, or, how do we maybe, because some of these are probably going to be in there more than 50 years. And what do we, are there ways that we can still get some benefit from them into the future?
Yeah, so if you consider the ponds for all of the other benefits, when you think about the ponds from recreational benefits, and if you think about it from a livestock watering benefit, they'll probably be beneficial in those regards for a long time. They'll turn into something that looks more like a wetland and probably a little drier in some seasons, but they'll still have a little bit of capacity. It might not be as good for fishing in the future. But if you think about what these 135 ponds that the NRCS put in were really designed for, and that was flood control of Soap Creek and Little
Mhm.
Soap Creek. And that is certainly diminished. To say that it's viable to go and dredge these locations or try to move that sediment back onto the landscape, that's a very expensive endeavor and very costly. I mean, I'm just kind of, speculating here a little bit, but I would say it's probably cheaper to go just build another dam somewhere. But certainly, I think that when we put in new ponds or even some of the younger ponds that haven't filled up yet, if we consider some catchment practices like some terrace structures or smaller pond dams in these catchments that could store a lot of that sediment, it's conceivable that you could, increase the life expectancy of these ponds by decades.
Okay. Somebody asked if it was possible. This was, I think, to Calvin, because they said, "Hey, Calvin," with an exclamation point. So, is it possible to replicate the bank erosion methodology you did on Old Man's Creek to compare sites with high quality riparian forest buffers versus pasture ag right up to the channel?
Sure, you can do it anywhere in the state.
Okay. Yep. All right, there are a couple that kind of related questions, and this is, now moving a little off the ponds to, I think, this bank erosion estimates and thinking about, what practices we might be able to use to be most effective for decreasing some of those stream bank erosion issues. Any thoughts on that one?
Boy, now we need to get Keith in
Yeah,
the
yeah.
room to start digging in.
Keith and Tom Eisenhart.
Tom
That maybe
Eisenhart,
this
I
is
think, would be the person.
something we should have a discussion of Keith. I should facilitate a discussion of Keith and Tom Eisenhart to maybe walk through some of these because to me it's not only in the stream, but we need to reduce that stream power as well. So we
Right.
reduce some of that transport capacity.
Yes.
Okay.
That's a whole nother presentation.
There we
Yeah,
go. Okay. All
we
right.
should Keith on for an ILF presentation on
On that one, I think we got another idea for our new format of just a dialogue that we asked
yeah.
Keith and Tom to come in and we could just see them. They could talk for quite a while on that. Let's see here. I think. Um, I think that is most of the questions that we have in there. If somebody has one that's burning, please type it in. I'll try to kind of wrap things up, I guess, by again reiterating if you're on and want to earn a CCA CEU, please email Alena Whitaker, ALENAW at iastate.edu by 5 o'clock today, including your name, the name you entered to watch the webinar, and your CCA number. Please tune in. Please tune in next week for our conservation tillage and soil health webinar. And then that's on Wednesday. And then on Thursday is Dan Anderson, Raj Raman, and Philip Roxon talking about um, manure and cover crops. So really, certainly important topic. Somebody asked about biologics for pond sediment you see biologics for pond sediment. Do these help with sediment? I don't know if either of you are in a position to answer that one.
Not really. It's kind of out of
Okay.
my wheelhouse.
Yeah. Same here. So sorry about that we're not able to answer that. I guess there was one, and this is may not be as again, this might be we need to get our forester folks on here, but you know, might there be increased runoff from these forest areas where there's invasive plants that might not be protecting the surface like some of our natives and, changing leaf litter and changing understory trees in there?
So, I mean, forested land, I think in general is probably a lot more erosive than people give it credit for. So, gully erosion in timberland and in forests is just a really prevalent thing. And we don't we don't notice it as much, maybe because we
We
don't
don't see
manage
it,
in those
or we
areas.
don't see it as broadly, right? Because
E- e-
it's in the trees. Sorry.
Exactly. But
Yeah.
I think that kind of regardless of, and certainly the changing understory and things like that will certainly affect these things. But we're seeing that it's not the sheet and rill, and it's not that type of erosion. It's the gullies in the forests, or it would be the gullies in the pasture land or the gullies anywhere. The gullies are really where that sediment is coming from. And generally speaking, because we don't manage those timberlands, once those gullies get started, they just keep going.
Yeah, and somebody brought up, kind of that some of these forested areas might have a greater slope, than
Mhm.
some of the others, and that, there might be some correlation why we see these gullies forming. So, yeah, kind of, yeah, quite a few gullies in these areas because of the slope that we might have there too.
Yeah, I mean, there's a reason that Soap Creek watershed isn't 90%
Yeah,
cornfields. It's because it's steep and sloping, and it's good cattle country and it's good
yeah,
timber ground. And so, yes, it's definitely a high sloping area.
yeah.
Yeah.
All
Yeah,
right.
I
Yeah,
remember about 15, 20 years ago where the DNR was looking to improve Lake Aquabi, and they were trying to find out where all the sources of the sediment were coming from, and it was all within their own forested area within that watershed. So they had to do a little work on their own property instead of talking to the farmers next
yeah,
door. It was in the forested areas,
yeah. So these,
and it was gully
these
erosion.
gully erosion that that you don't see as easily, but show up dramatically when you do things like LiDAR
Hmm.
elevation information. So, all right, Calvin and Matthew, thank you so very much for, first of all, the work you do. Certainly, with my hat as INRC director, really value the great research that you all have done and the contributions you've made to so many different research areas. And I also want to say thank you for always being willing to share and do a webinar on these topics. It's really important, really useful, and I want to thank you so very much for that.
You're welcome.
All right.
Thanks, Matt.
Yeah.